Welcome to Penrose Learning, where we make understanding easy.
You start by securing the essentials: power, compute, and I/O. Choose a board with GPU acceleration for models. A Pi 4 works for prototypes, while Jetson scales better. Once done, mount the camera and mic near the chassis for clear input, and wire motor drivers to the controller with common ground. Make sure to label connectors and test power rails with a multimeter before powering the system to avoid fried components. You now integrate software and the AI stack. Install a stable OS and enable SSH for headless development. Set up Python and Virtualenv, then install PyTorch or TensorFlow. Load a lightweight model and apply quantization to match your device's RAM and CPU limits. Once done, use ROS or a simple IPC layer to synchronize camera frames, audio input, and motor commands so latency stays low. Make sure to log sensor timestamps to debug timing issues later. You finish by calibrating sensors and validating behavior. Tune camera exposure, microphone gain, and motor PID until responses feel consistent. Run scripted scenarios for voice control, navigation, and emergency braking. Measure response times and adjust thresholds. Once done, containerize your application and set up auto start on boot for reliability. If things go wrong, check logs first. Most failures come from flaky power, loose.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.